Imagine you're aboard a spacecraft approaching Jupiter. From a distance, it looks almost serene. Swirling bands of cream and orange, that famous red spot, a storm larger than Earth. It's beautiful. But as you get closer, something feels wrong. The radiation alarms start screaming, your instruments begin to malfunction, and then you realize you're not approaching a planet. You're approaching a monster. Jupiter isn't the gentle giant of our solar system. It's a cosmic horror show hiding in plain sight. And by the end of this video, you'll understand why even our most advanced spacecraft barely survive encounters with it. Let's start with what Jupiter actually is, because most people don't truly grasp the scale we're dealing with. Jupiter is not just big, it's incomprehensibly massive. You could fit over 1,300 Earths inside it. Its mass is 2.5 times greater than all the other planets in our solar system combined. Every planet, every moon, every asteroid, Jupiter outweighs all of it twice over. But here's what makes this truly unsettling. Jupiter is almost a failed star. If it had been just 80 times more massive during its formation, nuclear fusion would have ignited in its core. We wouldn't have a planet. We'd have a second sun, a binary star system. Earth might never have formed at all. Instead, we got something perhaps more dangerous. A gas giant with no solid surface, crushing pressures, and an appetite for destruction that has shaped the entire solar system. Now zoom in on Jupiter's atmosphere. What you're looking at isn't weather. It's chaos on a scale that defies comprehension. The Great Red Spot alone has been raging for at least 400 years, possibly much longer. This single storm is large enough to swallow Earth whole, with room to spare. Wind speeds at its edges exceed 400 kilometers per hour, and that's considered calm by Jupiter's standards. Deeper in the atmosphere, jet streams tear across the planet at over 600 kilometers per hour. These aren't gentle breezes, they're walls of gas moving faster than the speed of sound on Earth. But the storms aren't the scariest part. The deeper you go, the worse it gets. Jupiter has no surface. There's no ground to land on. The atmosphere simply gets thicker and thicker, the pressure rising with every kilometer. At a certain depth, the pressure becomes so extreme that hydrogen, a gas we breathe on Earth, transforms into liquid metal. Liquid metallic hydrogen. It sounds like science fiction, but it's real. And it's responsible for something far more terrifying. Jupiter's magnetic field. Earth has a magnetic field too. It protects us from solar radiation, deflects charged particles, makes life possible. Jupiter's magnetic field operates on an entirely different scale. It's roughly 20,000 times stronger than Earth's. If you could see it with your eyes, it would appear larger than the full moon from Earth's surface. It extends millions of kilometers into space, reaching all the way to Saturn's orbit, the largest structure in the solar system. And it's invisible. But here's the catch. This magnetic field doesn't protect, it destroys. Jupiter traps charged particles from the solar wind and accelerates them to near light speed. These particles form radiation belts so intense that they would kill an unprotected human in minutes. Not hours, minutes. When NASA's Juno spacecraft entered Jupiter's orbit, it had to carry a titanium radiation vault just to protect its electronics. The vault weighs 200 kilograms. And even with that protection, Juno can only make close passes for a few hours at a time before the radiation threatens to fry its systems. The Galileo probe, which plunged into Jupiter's atmosphere in 2003, received a radiation dose equivalent to 25 million dental x-rays before it was crushed and vaporized. This is not a peaceful planet. And we haven't even discussed what Jupiter does to everything around it. Jupiter is a cosmic wrecking ball. Its gravity is so immense that it fundamentally altered the formation of the solar system. Scientists believe Jupiter migrated inward during the solar system's early history, scattering debris, absorbing would-be planets, and preventing Mars from growing to its full potential. There's a theory called the Grand Tack hypothesis. It suggests Jupiter wandered as close as Mars's current orbit before being pulled back outward by Saturn. During this migration, it would have destroyed or ejected most of the material in the inner solar system. This is why the asteroid belt exists. It's not debris from a destroyed planet. It's debris from planets that never got the chance to form because Jupiter wouldn't let them. But Jupiter's gravitational influence isn't just historical, it's ongoing. Comets, asteroids, rogue objects drifting through the solar system. Jupiter acts like a gravitational vacuum cleaner. It either absorbs them, deflects them into the sun, or flings them out of the solar system entirely. In 1994, we watched this happen in real time. Comet Shoemaker-Levy 9 was captured by Jupiter's gravity and torn into 21 fragments. Then, one by one, those fragments slammed into Jupiter's atmosphere at 60 kilometers per second. The impacts left scars larger than Earth. The energy released was equivalent to millions of nuclear bombs. If that comet had hit Earth, instead, extinction. Some scientists argue that Jupiter protects us from such impacts. Others point out that Jupiter's gravity also sends objects toward the inner solar system, increasing the risk. The truth is probably somewhere in between. Jupiter giveth, and Jupiter taketh away. You might think that at least Jupiter's moons are safe. After all, Europa has a subsurface ocean. Ganymede is the largest moon in the solar system. These are places we hope to find life. But even Jupiter's moons exist in a radiation hellscape. Io, the closest large moon, is the most volcanically active body we know of. Not because of internal heat like Earth, because Jupiter's gravity literally kneads it like dough. The tidal forces are so extreme that Io's surface is constantly erupting, reshaping itself every few years. Europa, the moon with the promising ocean, orbits within Jupiter's radiation belts. The radiation on Europa's surface is lethal. Any spacecraft that lands there will have to drill through kilometers of ice just to have a chance at finding shielded water below. These moons aren't refuges, they're prisoners, trapped in orbit around a monster. Let's pause here, because I want you to understand the full picture. Jupiter isn't just dangerous in one way, it's dangerous in every way simultaneously. The pressure crushes, the radiation kills, the gravity traps, the storms destroy, the magnetic field accelerates particles to relativistic speeds. There is no safe approach to Jupiter. There is no safe orbit around Jupiter. Every mission we send there is operating on borrowed time. And here's the part people overlook. Jupiter is still actively shaping the solar system. Its gravity influences the orbits of asteroids, the trajectories of comets, even the subtle wobble of the sun itself, in a very real sense. So why do we keep sending spacecraft there? Because the terrifying things about Jupiter are also the most scientifically valuable. That liquid metallic hydrogen interior, it could teach us about the formation of gas giants throughout the universe. Jupiter's radiation environment, it's a laboratory for understanding magnetospheres and charged particle physics. The moons, potential habitats for life. If anything can survive in Jupiter's shadow. Juno has been orbiting Jupiter since 2016, and the data it's returned has revolutionized our understanding. We've discovered that Jupiter's core isn't solid like we thought. It's a fuzzy, diffuse region, possibly still absorbing material from impacts billions of years ago. We've learned that Jupiter's atmospheric dynamics extend far deeper than expected. The storms aren't surface phenomena. They penetrate hundreds of kilometers into the planet. And we've confirmed that Jupiter's aurora, the glowing lights at its poles, are powered by interactions with its moons. Io's volcanoes spew material into space, which gets ionized and funneled along magnetic field lines, creating light shows that dwarf anything on Earth. But even with all this knowledge, Jupiter remains fundamentally alien. We will never walk on Jupiter. There's no surface to walk on. We will never establish a base in its atmosphere. The pressures and radiation make it impossible. Even robotic exploration is limited. Our best spacecraft can only survive for years in Jupiter's vicinity, and even then, only by carefully managing their orbits to minimize radiation exposure. Jupiter represents a hard boundary, a place we can study but never truly inhabit, a constant reminder that the universe wasn't designed with human survival in mind. Here's the sobering reality. Jupiter has been here for 4.5 billion years. It was here before life existed on Earth. It will be here long after humanity is gone. And during all that time, it has never stopped being violent, never stopped being deadly, never stopped being hungry. When you look up at the night sky and see Jupiter as a bright, steady point of light, you're not looking at a peaceful neighbor. You're looking at a storm that's been raging since before the dinosaurs, a radiation source that would kill you in minutes, a gravitational well that has shaped the fate of worlds. Jupiter isn't the king of the planets because it's noble. It's the king because nothing else survived long enough to challenge it. I hope this gave you a new perspective on the gas giant we thought we knew. The solar system is far more violent than it appears, and Jupiter is the proof. If you enjoyed this video, consider subscribing, and I'll see you next time.